Welcome back. We continue with the definition of the terms used in statistics. In the previous video, we have discussed about the parameter that are the measures obtained from the population, and the statistic are those measures that are related to sample. We also discussed about the different notations used in population and sample. Now, let us suppose that this is a snapshot of the data collected from those employees, and we have the employee ID, employee name, their address, their experience, education, skill score, age, and salary. And we are interested in finding out any relation between the salary structure or the salary figures here with the features or with the variables here, that is employee ID, e-name, address, and like that. And by intuition, we can say that a salary structure does not depend upon this employee ID or name or address. Rather, it depends upon experience, education level, skill score level, and age, that is seniority, right? So, we filter out this part of the dataset with only experience, education, skill score, age, and salary. And after filtering out, we notice one thing, that this is a row that is related to Mr. Ravi, and this is another row that is related to Miss Ashwini. Now, when we are considering the whole dataset, then these two rows were unique. But whenever we have filtered out, then these two rows are copies of the same data values, right? Same thing goes over here and here. So when we go for filtering out this dataset, we will keep one copy of the redundant rows. Okay. So we have the filtered dataset like this with unique row values here, and we have 10 rows out of the 12 rows in the previous slide. Now we are interested in salary. That means we are trying to figure out the value of the salary. So this is a response variable or the dependent variable. That means the salary is dependent upon some other variable. Now those other variables are explanatory variables that have the power to determine the value of the salary or the response variable. So here the experience, education, skill score, and age, these variables have the power to determine the value of the salary. Of course, you see here may help. That means we are not sure whether this experience, education, skill score, or age have any influence on the salary values. So we have written here may help. Now, how will you know actually whether these variables are having any influence on the salary? That you have to go for finding out in the experiment following some statistical model, right? Now, this explanatory variable is under control of the experimenter. That means the value here 8.1, 6, 22.7, these values or these bachelors, this B, B++, and all those stuff, these variables are under control of the experimenter. Now, specifically in this case, it is not actually, because these are observed data that belongs to the employees of the factory. So for explaining this controlled by experimenter, this statement, I will take help of this. Suppose there is a milk packing machine and the power is input to the machine as well as the throttle here. The power is actually controlling the RPM, say, of the machine, and the throttle is controlling the amount of milk that is passing through the pipeline, right? Now from the machine, we are reading the packet weights of each packet that is coming out of this machine, right? Now the question is whether this packet weight is dependent upon the power or the throttle. Now the experimenter can change the power, that is the voltage or the ampere, or the throttle may be changed, and then the packet weights may be read to figure out whether there is a change in the packet weights due to a change in power or the throttle. If it is observed that there is a change in the packet weight due to change in power or due to change in throttle, then it can be inferred that the power and the throttle have effect on the packet weights, right? So this power and throttle will be explanatory variable and the packet weight will be your response variable. But in this case, the experimenter is not having any control over the data because these are the data that belongs to the employees. So if this first row belongs to Mr. Ravi, so you cannot change Mr. Ravi's experience from 8.1 to some other value, right? But you can have an analogy like this, that this is a row that belongs to some employee, and see this row that belongs to some other employee. Here you see that bachelors and bachelors are matching, as well as 26 and 26 are matching, but there's a change in the experience from 2 to 1.2, that is experience is going down, and here also the grade is A++, and it goes down to C++. So there's a downgrade here also. And we have an effect that 56,000 salary is going down to 26,000 salary. So you can say that the experience and skill score, both these variables have an effect on the salary values, right? Next, explanatory variable may be categorical, that is education and skill score. So these are non-numeric data, and the variables that holds the non-numeric data may be called a categorical variable. So this is a categorical explanatory variable, and the experience and the age, these two variables are continuous explanatory variables because these are numeric data. So you can see that 8.1, 22.7, and here there are numbers. So experience and age are continuous type explanatory variable, right? Now the explanatory variable may be fixed or random or mixed as per statistical model used. So the data may be fixed, or you can generate the values in a random fashion to feed the input values to a system. It depends upon the statistical model you're using. Now we go with this, that factor. So do not be confused with the factors that all the explanatory variables are factors. It is not true. Those explanatory variables that are categorical, okay, so those are actually we call factors. So here, education and skill score, these two variables are factors. Experience and age are not factors. They are just explanatory variables, okay. Next, we define levels. It is nothing but those values of a factor. So education is having masters and bachelors, these two factors, and the factor skill score is having 7 values or 7 levels. Now we go with the treatment. It is telling a particular combination of values for the factors. That means masters can be combined with C++ and we have a treatment. We can also have a combination of masters with A++ and that is a different treatment. So we can have the treatments like this. So we have 7 treatments in total with masters. Also with bachelors, we can have the 7 treatments like this. So in total, we can have 14 treatments. Now you notice the combination here. Bachelors is combined with B-. And here also the bachelors and B- is a combination. So the combinations are appearing in 2 separate unique rows, definitely. But when you count the treatments, then you should omit the redundant treatments and you will count only 1 copy of those redundant treatments.